friends, so we're back to our savings account on the board. In the beginning of the account, we deposit $100 into it. Now, in year one, if you remember, the way we worked out year one before was we took the original $100 and then we added 1% of that $100. Let's write that more mathematically efficiently, because the problem with that is there's nothing wrong with it mathematically. It's perfectly fine. The problem with it is having to write the $100 twice seems a little excessive. It seems like we should be able to combine it all together into one use of the $100. So here's what I recommend we think about. I'm going to do this in a different color marker and then erase it. This right here is 100% of $100. 100% of $100, no big deal. This is 1% of $100. Again, we already knew that because we wrote it up there. If you add those two things together, hopefully this makes sense. 100% of $100 and 1% of $100 is going to be 101% of $100. Hopefully that makes sense. I mean, you can, since you have the same base of $100, you can just add the percentages. That, I think, is an easier way of writing $100 plus 1% of $100. So what I'm going to do is, I'm going to rewrite it as that. I'm going to rewrite this as 101% of $100. And you know what? As I'm writing that out, I think we can write it. I think we could write it even better. I'm going to tell you. I've told you already. There's certain things I don't like in the world. Using Blackboard, for example. I also hate the percentage symbol. And you know why? It's quite simple. If you actually have to do math with percentages, you can't use this symbol. You have to change this thing to a decimal first. So 101% of $100, if you wanted to actually do this like in a 4-function calculator or Google, for example, and you wanted to make sure you got the context right, you'd have to change this to 1.01 times $100. 1.01 times. This means the same thing. Both of these things are the same. 1.01 times 100 and 101% of $100. It's the same thing. The 1 in decimal form stands for 100% and 0.01 stands for 1%. And you know what? Actually, because this dollar sign is a little bit, because it's a symbol and I want to draw attention to that, I'm going to reverse these and have it be $100 times 1.01. That even looks simpler than that to me. I think that looks even better. Okay, so what I'm going to do is I'm going to erase all this and replace it with that. All of these things that I'm erasing mean the same thing. I'm just trying to get this written more conveniently. So what we're going to do is we're going to write $100 times 1.01. That actually does look a lot simpler than it did before when we had, something plus something else. Okay, cool. Now, I'm going to write what that equals next to it. We know it equals $101. We figured that out last time. In order to get the next year, year 2, I no longer want to go back and do it the old way now. Now I want to do it the new way. And the new way is taking the previous amount and multiplying it by 1.01. I think I want to do that. Take the previous amount, $101, and multiply it by 1.01. then I think if I remember correctly, we figured out that that was equal to like $102.01. I'll put that in blue over here. However, I just happened to notice something as I was walking back and forth. This is going to get a little bit arrowy and boxy and drawy, but I think we can figure something out here. You see this 101 right here? I'm going to make that blue. Just because it's blue over there. I'm going to erase this for now. That $101 is the same as this $101 over here. And I can't help but notice that that $101 is the same as this. So what I'm thinking maybe what we do is we take this expression and put it in place of this. So follow me here. I'm going to take $100 times 1.01, and then don't forget times 1.01. And you got to realize why there are two of them. This 1.01 was the interest earned from year 0 to year 1, and this 1.01 was the interest earned from year 1 to year 2. So if you look at this, what you're actually seeing is $100 times 1.01 times 1.01. Now, it might be easier if I take some of this color away. If I take some of this color away and simply rewrite this line 2 with this all in black. So if you follow the logic here, the math here, from year 0 to year 1, we multiplied by 1.01. That is equal to something. It's equal to $101, but it's not important to know that number. I think it's actually better to leave it looking just like this, 100 times 1.01. Then to go from year 1 to year 2, we just take 101% of that, which is now here. Which means in year 3, we take 101% of this. And now maybe, are you seeing the exponential behavior of this? Maybe you're not. It's okay if you're not. Do you see how in year 1, there is one of these factors multiplied by 100? So if you think about it, I'm going to use, let's use green. This is equal to 100, you know what, let's not make the whole thing green. Let's make just the exponent part green. Let's make most of it black and just the exponent. This is equal to $100 times 1.01, and there's one of them, so I'm going to put that to the first power. This one here is $100 times 1.01, but there's two of them multiplied together, so that's squared. This one here is $100. You are in a really bad place, string. Times 1.01, and that's cubed. And I think you're seeing where this is going. In year 4, it's $100, and there's going to be those 3 1.01s, and then the additional 1.01, so it's going to be to the 4th. And hopefully you're seeing this. It means the years match the power on the multiplication. As a matter of fact, if you remember, it depends on what math class you had last, or even if you ever learned this, technically speaking, the 0 is also in there. I'll ask you for that for an extra credit question on your homework. But there's actually, the 1.01 can actually be expressed up up there. And you know what I'm really excited about? This is even cooler. What I'm even more excited about than anything is before, in order to say, for example, get to year 5, we had to know what year 4 was. And then we had to know what year 3 was. It's almost like the factorial stuff from the first couple days of class. The reason the factorial was so good was it allowed us to jump from 1 to 52. If we wanted to know how far, or excuse me, if we wanted to know how much money we were going to have in our account after 30 years, we wouldn't have to figure out what 29 and 28 and 27 and 26 were. All we'd have to do is you take your starting amount, which in this case is $100, and you multiply it by that rate you got to that many years. Because each of those years multiplies it by an additional 1.01. So I think we've actually stumbled upon something pretty rad here. I think we've actually stumbled upon something pretty rad. I'm going to move the camera over here, and we're going to write it on the board here, and we'll regroup, and I'll put it in. I'll make it pretty in a PowerPoint later. But I think we've just discovered something about financial math with exponential modeling. Let's stop that from wiggling. So exponential, and I'm going to put financial math modeling. So far, what we've got is, if you take your starting amount and you multiply it by a rate, and the exponent is the number of years, you end up with your ending amount. This is actually pretty cool. So if you know how much you deposit, starting amount being a deposit, maybe that's a better word, deposit. You can figure out your future value if you know the rate and you know how many years you're going to leave it in. And that, my friends, is pretty powerful. It's pretty powerful. What I'd like to do now is to go back in to our spreadsheet and figure out what is constantly happening. Remember how we tried to make it be a line and it didn't work because the amount was getting bigger as we went down? There is something, and now I think we see it. You might not see it here, and that's okay if you don't. But there is something that's constant based on, I'm trying to point right now, it's harder than I thought. There is something constant that's based on those results right there. Let's go back in and take a look at the spreadsheet one more time.